Chapter 3 is all about solving inequalities, and Chapter 3, Section 1 is specifically about inequalities and their graphs. This is a one-day lesson, so by the end of today, you should be able to graph a linear inequality on a number line and then write an inequality that models a real-world situation. Remember first, when we're starting out, that an inequality is a math sentence that uses an inequality symbol, like these four below, to compare the values of two expressions. Okay, so this time, instead of just having a number with another number and deciding which one's greater than or equal to, we'll have two expressions. Okay, when writing and solving inequalities, we use a number line to show all the solutions that would work in the inequality. So we are actually going to be shading in on our number line every number that could go in for this variable. All right, so what I hope that you will do is when you make your number line, you need to at least have three numbers, at least. The first number that you're going to need is whatever number they give you. So I'm going to put my 10, then I'm going to put a couple more on each side. All right, next, we have to decide if I'm going to have an open circle or a closed circle. If you remember those from last year, open circles work with greater than and less than because it does not include that number. Closed circles works with anything that has the equal to bar, greater than or equal to or less than or equal to. All right, so in this case, because I do not have an equal to bar, I'm going to be putting an open circle at the number 10. All right, so my numbers that would fit on this side have to be numbers that are less than 10 because my y is on the less than side. So I'm going to color in every number that is less than 10 on my number line. So all of this is going to get colored, and it doesn't end there, so I have to make sure and put an arrow because then I'll know every number to the left would work for this inequality. All right, now knowing what you know, we're going to try to graph all three of these. So on the first one, I need to have at least three numbers. So I'm going to put -2, -1, -3. I know that I'm going to need a closed circle because I have that equal to bar. So a closed circle at -2. That means that -2 is also a solution to this inequality. And because my k is on the greater than side, I'm going to shade everything that is greater than -2. All right, a great way to check to see if this works is to choose a number that you have shaded in. So over here, this would be 0. If I put a 0 right here, is 0 greater than or equal to -2? Yes, which means it should be shaded and we did the right thing. All right, m is less than or equal to 6.5. Means I'm gonna go 6, 7, and 5, and maybe even a 4 and an 8 since they fit. All right, because I have an equal to bar right here, that means I'm going to have a closed circle at 6.5. And then because my m is on the smaller or less than side, I'm going to shade everything that is less than 6.5. All right, last on this page, I have a 0, so I'm going to put 0, and this one has a lot of room, so I'm going to put in a few more numbers. All right, there is no equal to bar, so I need an open circle at 0. And my x is on the open or the greater than side, so I need to shade in anything greater than 0. Okay, write an inequality to represent the following, then graph that inequality. So they're going to give us a word sentence that we need to turn into a number sentence and then use that to graph it. So all real numbers x. Okay, this whole phrase right here really just means x less than or equal to, that gives us our symbol, -7. Okay, so I have x is less than or equal to -7. Okay, so that means on my number line, I'm going to put a -7, -6, -5, -8, -9. Okay, and then because it says less than or equal to, that means I need a closed circle at -7. And I'm on my variable's on the less than side, so I need to shade everything that is less than -7. Okay, second question says 6 less than a number k is greater than 13. Now this is tough because we have both less than and greater than, but what I need you to look for is this word. This is kind of our separating word. Right here, this is all a number phrase, an expression. 6 less than a number k. So that means k minus 6 is greater than 13. All right, now how do you graph that? We have to solve it first. Okay, you're gonna just pretend or do this as if your inequality was an equal sign, and then do the same steps you would to get k by itself. Opposite of subtracting 6 is adding 6. So we will have k is greater than 19. All right, so I'm gonna put 19 and 20 and 18 on my number line. I'm going to put an open circle at 19 and then shade everything greater than that. All right, this would be a great place to try it on your own. So if you want to pause here and then come on back and see if your answers match mine. All right, I'm glad you're back. Hopefully your answers match what I have here on this slide. The solution of an inequality is any number that makes the inequality true. And it's very possible to have more than one answer. When you have inequalities, there can be infinite numbers of answers. Okay, so for example, is this number a solution? They give us two possibilities. The best way to find that out is to plug this number in for the x and then try it with this number. So we're going to start with -3. We'll have 2 times -3 plus 1 is greater than -3. All right, well, first step would be to multiply. So we get -6 plus 1 is greater than -3, which says -5 is greater than -3. Is -5 greater than -3? It is not, so this is not a solution. Then we're going to try -1. 2 times -1 plus 1 is greater than -3. -2 plus 1 is greater than -3. -1 is greater than -3, and that is true, so -1 is a solution. All right, consider the numbers -1, 0, 1, and 3. Which numbers are solutions of this inequality? There's two ways to do it. You can test each point like we did before, where we would plug in -1, 0, 1, and 3 and get 4 different answers. Or you can solve this inequality and get y by itself. Let's try that one first. Okay, I'm going to start with 13 minus 7y is less than or equal to 6. All right, I'm going to start by subtracting 13, which leaves me with a -7y less than or equal to -7. Then I have to divide by -7. And if you remember from 7th grade, anytime that I divide or multiply by a negative number, I have to change the direction of my inequality symbol. So I have y is greater than or equal to positive 1. Okay, so that means any answer up here in my options that is greater than or equal to 1 would be a solution, while the other ones would not. So that means 1 and 3 would be solutions, -1 and 0 would not. Okay, now they're going to switch it and give us the graph like we've been doing, and we're going to have to write the inequality. My suggestions for doing that are to first write down the number and the variable, and then we'll figure out which way the sign goes and what sign we're using. Okay, so I'm just going to use x's because it's easy, and I know that I have this -1. That's where my dot is. Okay, because this dot here is all filled in, that means I am going to have an equal to bar on the bottom, and all of the numbers that are shaded happen to be numbers that are bigger than -1, so my x values are greater than or equal to -1. Okay, second one, I'm going to put my variable and the number 4. It is an open circle, so I do not have an equal to bar underneath my inequality symbol. And I see that all my numbers that are shaded are less than 4. Okay, let's give these a shot. Letter A, I have a variable and I know it's at -3. I do not need an equal to bar because it's an open circle, but all these numbers shaded are less than -3. Letter B is going to require an equal to bar, and all of the numbers shaded are greater, oops, sorry, that shouldn't be a 4, it should be a 0. All of the numbers are greater than or equal to 0. All right, real life situation. This one says that trail rides are starting at $19.99. That means some of them might cost more than $19.99, but some of them might be equal to $19.99. So I'm going to put T, and I'm going to put $19.99. And because I know that one of the trail rides could be equal to $19.99, I'm going to put the equal to bar. But I also know that they could be greater than, because that's just the price that they're starting at. Okay, and then remember it says be sure to define a variable, so I'm going to say that T is equal to trail ride cost. Okay, 8 miles per hour, that speed limit sign means that 8 is probably the lowest that I should go. Actually, that is the highest I should go because it is a speed limit sign. I'm not sure where that one's from. But it's speed limit means my speed could be equal to 8, probably should be equal to 8, but it also could be less than 8. Okay, and M is going to be my speed. All right, this would be a great place for you to try this out on your own. Define a variable and write an inequality to model each situation. Come back here in a few minutes when you've finished, and then you can see what my inequalities are. All right, if you have any questions about any of this, make sure you find me, contact me. Your homework tonight is actually a worksheet that I'll attach to today's post.